Hello again, everyone. Lesson 1, Lesson 2, Lesson 3, Lesson 4, Lesson 5. This is Lesson 6 in our Statistics Made Easy series. Today, April 30th, 2020, we'll be looking at Anova post-hoc analysis. In the last lesson, we looked at Anova, its brief history, mathematical model, how to use it, when to use it, how to report it. Today, we will learn when to conduct Anova post-hoc analysis and the type of analysis we should deploy and how we write the results after conducting the post-hoc analysis. The class is now asking me a question. So what is it now this time? What does post-hoc mean? All right, class, post-hoc means occurring or done after the event. Another question from the class I can say is, which event? I talked about an event last time. Which event? The event is when you get a significant ANOVA. So you want to be a detective to know which group is responsible for the significant difference. It's like a doctor performing a post-mortem to find out what killed the person. Another question is coming up. What if we do not have a significant F? Oh, I thought I had answered that question implicitly. It means you are not concentrating. It means you are drinking too much water. So don't drink water while studying, because chemistry says that concentration decreases on adding water. So back to your question. What if the ANOVA is not significant? It's case closed. That's it. Now I'm going to ask you a question. Do you agree that the use of social media for non-academic purposes will increase as a result of COVID-19 lockdown? Do you agree with that? I actually asked this question in the survey I conducted with the class. Let's see how that survey went. So this is the questionnaire to which you responded. We have 47 respondents. Questionnaire to collect data for this course. We asked for demographic data. We asked for all of the specialization. So for specialization, we had those in STEM education group, ICT education group, pure science, and all of this. And we asked for a class of degree. And then relating to assessment of the effects of COVID-19 on the educational system. One of the items which we are going to be focusing on today is this. Properly, we looked at that the last time. Use of social media for non-academic purposes will increase. We have to strongly agree, disagree, and we scored them. So that was the question. We asked. Do you agree that the use of social media for this will increase as a result of COVID-19 lockdown? So when we conducted the one-way ANOVA on it, we looked at specialization, STEM education, specialization, ICT education, social sciences, pure sciences. So these are the means, 12 of them in STEM education, 1.5 mean, ICT education, 11.5 mean. These are the standard deviations. And then when we conducted the ANOVA, we got a significant F value, 4.22. You can abbreviate or you can let that to be two decimal places, 4.23. And see a level of significance 0.012, which is less than 0.05. So people get confused. Is 0.012 less than 0.05? Surely you can say 0.05 if you are coming down 0.05, 0.04, 0.03, 0.02, 0.01. So 0.01 is there, so it's less than 0.05. So let's now go on to look at the procedure for conducting post-hoc analysis when we have now found that the F test is significant, ANOVA is significant. The question is coming out from the class again. How many post-hoc tests? There are so many post-hoc tests. Yes. Can you recommend the best? Okay, I'm going to ask you, class. Can you tell me the names of some of these post-hoc tests? Yes, Ibukun. Ademola is saying that, okay, 2K test, right? Henry Okore, what about you? Henry Okore is saying Sheffield. Fred Awa from Ghana. Oh, Fred is also agreeing with Ademola saying 2K test. Now, there's a marketplace of tests of post-hoc. What did I say? Marketplace. You find tomatoes, you have onions, you have melon, you have everything there. Plenty things. Look at, I've just listed 11. Bonferroni procedure, Duncan's new multiple range test, Jones multiple comparison test, Fisher's least significant difference, LSD, Home, Bonferroni procedure, Newman-Kuhl's, Rogers method, Sheffield's method, 2K test, Dunet's correction, Benjamin Hodgberg procedure. I tell you a little story. While I was doing my PhD, I decided to confuse some people, and I used as many of these as possible. And they were all giving me the same results. I know they would give me nothing too significantly different. But it took the joy of saying, well, I used the Bonferroni test. And in our class, you have people saying, okay, I used Anova, it was significant. I used the home Bonferroni procedure. I used the Mancules. So it was quite fun in those days. But my view is this: whichever one you want to choose is a matter of preference, because most of the tests have the same characteristics and requirements, and their results are generally similar. You see this in a minute. In my case, I prefer the 2K HSD. That's the honestly significant difference. And also Sheffield because both of them, because they are very conservative. What's the meaning of conservative? Conservative means that they will apply very stringent conditions to make them to be significant. Very stringent conditions. But you can get the difference between the 2K and the Sheffield, because you see, if you have the same number of students in the group, or if you are doing pure science, you have the same number of elements in a group. If you have 3 groups, for instance, group A 10 students or 10 people, 10 elements, group B 10, group C 10. You have the same element, you use the 2K. But when they are different, you have group A is 8, group B is 16, group C is 9. So Sheffield will come in handy. So let's look at its research question that we want to use for this lesson. Is there, or will there be, either is correct, statistically significant difference among STEM education, ICT education, social sciences, humanities, and pure science students in their perception that the use of social media for non-academic purposes will increase as a result of COVID-19? That's a step one. Of course, we need a hypothesis. And a null hypothesis, by the way, it didn't always be null hypothesis. If you want, it's actually optional. You can decide to have the alternate hypothesis or the research hypothesis. That would be like HA or H1. So for me, I like to state it in null form. There will be no, and I go on with the rest, and I go on with the rest. I set my alpha level at 0.25, meaning that I'm 95% confident that I will not see any statistically significant difference among these 4 groups. So let's conduct the F test or Anova. This is our class data. We have names here. Actually, I think about 40 something here. Students, I'm only able to capture this on this screen. Specialization will be STEM education, ICT education, and all of that. The B11 is the variable on the use of social media. So which statistical tool should we use? Well, this statistical tool for our class, IBM SPSS. How do you get it? You get it from your school, or you purchase online or anywhere else. So I've often underlined this. That's very important. Do it yourself. Do not depend on mercenaries to analyze your data for you. They will collect your money and do rubbish. They will cook your results, and then your integrity will be compromised. And when you are defending your thesis or project report or dissertation, they will not be there, and then you'll be thoroughly messed up. So what are we waiting for? Let's begin our F test. We have our data. We have SPSS. So the way to go is quite simple, like the SPS, the one we learned in lesson 5. You go to analyze, you go to compare means, go to one-way ANOVA, and then you complete the dialog box. But the difference here is that you have to include the selection of the post-hoc tests that you want to do, and then you click OK. Yeah, so let's see how this thing runs in practice. So in practice, these are raw data. We'll go to Analyze, Compare Means, because we are comparing the means of those 4 groups. And then we'll come here, we'll come to one-way ANOVA. In one-way ANOVA, we have specialization is a factor. Okay, the dependent list is this one, use of social media. We'll put this one there. Specialization is this one, a factor. And then contrast, anything to do here? Well, nothing. Don't bother about contrast. Post-hoc, yeah, you know, we're here for post-hoc. So look at them. LSD, Bofferoni, SIDAC, Shefi, all of this. Let's even do something interesting. Let's take all of them. Let's just take all of them. I'll find out if we have anything too different. Tukibi, don't care. Well, let's leave out this other bit. And then we'll say continue. And then we'll say okay. So where are our results? So you can see that one-way ANOVA is significant, and then these are the post-hoc tests. So let's take them one by one. Let's take the Tukey honestly significant difference, and what you interest you will be this column here, this one. This column here is you can see. The one that is significant is what we'll be looking for. Look, the combination that is significant is actually doing multiple t-tests. Checking this group with this group, checking this group with this group, checking this group with this group. This one with this one with that. So let's look at this first one. 2KHS, the STEM education and ICT education. Any significant difference there? Yes, you can see is significant. So note this. The others are not. ICT education and STEM education, just repeating it, you can see 0.06, 0.006, just repeating that. So that's for 2K. Let's look at Shefi. So in 2K, we can see only STEM education and ICT education difference causing this significant ANOVA. So this is the culprit, in quotes now, the culprit. Let's look at Shefi. Shefi 0.013, this is significant. And let's see, any other one significant, 0.013, see the same. ICT education and STEM education. So the same culprit is what Shefi, using different detectives. So Detective Tukey has picked out STEM education and ICT. Detective Shefi has picked out STEM education and ICT. But you can see you can see that this is more conservative, 0.013, this 0.006. So it's easier to get significant difference with Tukey, with Mr. Tukey. Let's go to LSD. LSD, you can see STEM education is also the same. Detective LSD has detected STEM education and ICT, just the same one. Let's look at another detective, Bonferroni. Bonferroni is doing STEM education and ICT, just that one too. Let's look at SIDAC. SIDAC is the same. Yeah, you actually can see that SIDAC, the result of SIDAC is not too different from that of Bonferroni, 0.007. Then, okay, so that's it. So that's how we conduct this. So the result is that the culprit, I'm putting that in quotes, the two groups that are causing the difference to happen in ANOVA is STEM education and ICT, the difference between the two of them. So we have done, we've been to action, we're back in class. So what's next? What is next is step 4, to present our ANOVA tables. And you can see in the ANOVA table, you give us the different groups, the end, mean, and standard deviation, like we learned in lesson 5. Here, you do your ANOVA, and you can see 0.012, that's for Shefi. Yes, let me go back one step. In go back one step, you know I mentioned to you that I like Shefi, and that's what we are saying on there. So go to compare means, go to one-way ANOVA, and then let me reset the whole thing. And then, of course, use of social media is the dependent list. That's a dependent variable. Specialization is the factor. Post-hoc, yeah, I'm only doing Shefi here because I love it. is conservative, so I say continue, and then we'll get this. So this is what I was getting on that page. So the F is 0.012, and you can see this is the Sheffield table that you need to put in there. So you make a note of the let's see, the means and the standard deviation. Let's see that we have which we had here. You make a note of the mean and standard deviation of the make a note of this mean. So yeah, here you make a note of the mean and the standard deviation. So that's what you're going to get on the other page. Yeah, so this is it. We have the mean, the standard deviation, and then the F value, which is significant. We have the significant F. And as we mentioned, you have to go put this summary. F in brackets, the degrees of freedom between 3, this one, within this is equal to 4.225, which you can abbreviate to 4.23, excuse me, P less than 0.05. This one is less than 0.05. That's why it is significant. After that, you present your post-hoc table. That's the post-hoc table is a Sheffield, which I selected, and then you can see that this is 0.013. This is the only significant one. The STEM education and the ICT, these are the two that are causing this difference, statistically significant F, to happen. So number 5 is state your decision on the hypothesis. We said that there will not be any statistically significant difference among these groups on this measure. We found that there is statistically significant difference. So, okay, this is the statistically significant difference. F337 is equal to 4.23, P less than 0.25. So our decision is, since we found a significant difference, so we have to reject the null hypothesis of no significant difference. So where lies the significant difference? That's the report of the post-hoc findings. So you need these two tables. This first one, which shows STEM education, ICT education, see their means 1.5, 2.63, and see their standard deviations. And the Sheffield test shows that it is significant. This is where a significant difference is coming from. So this is a very important slide. How do you report post-hoc findings? You report it as follows. There was a statistically significant difference among the 4 groups of students in their perception that the use of social media for non-academic purposes will increase as a result of COVID-19. Then you put your F. F337 is equal to 4.23, P less than 0.25. Please and please and please, you don't have to say the calculated F is so and so, the table F is so. Nobody's looking at no table. This has already assumed check with the table value. So you then go on to say post-hoc comparisons using the Sheffield test indicated that the mean score for the STEM education group, so you put the mean there at the standard deviation, was significantly different, and you put that alpha level there from the ICT education group, and you put the means there. So look at the means that I was talking about. So these are the means and standard deviation, and this is the one. So those are the things that will appear in the report or your post-hoc findings. This slide is extremely important for your thesis, dissertation, and for articles that you're going to send to learned journals. Okay, so to sum up, what did we learn in this lesson? We learned how to conduct and report Anova post-hoc test. End of story for post-hoc test, but not end of story for Anova. Why is that so? Because in the next lesson, this lesson we only looked at one-way Anova. The next lesson we'll be conducting two-way, three-way, and multi-way Anova. Multi-way just means 3, 4-way, 5-way, 6-way, 1 million way Anova. Last slide before I go. Now, do you know why plants hate maths? They do so because it gives them square roots. Square roots, their roots become square. Well, for me, Peter Okebukola, it is Bye for now. This is my email ID. If you have any questions or observations, please get in touch. Again, bye-bye from me. Till the next lesson.